Traditional web scraping is dead. Imagine you're spending weeks setting up a system to collect data from the web for your business. The website structure changes, and suddenly your data collection stops working. This is a common challenge everyone faces who collects data from the web, unless you're using AI. I'll show you how I solved this headache and built this AI-powered scraping dashboard. Even if a website completely redesigned their pages, my scraper still pulls the right data, and no code changes are needed. That's the power of combining traditional scraping with AI. By the end of this video, you'll know exactly how to scrape with AI, save money on tokens, and build a complete dashboard like this one. I'll compare 6 different approaches using the same test case. First, a job board, which can easily be scraped without being blocked. And then second, a real estate listing site from Argentina with anti-bot measures. Let's start with Beautiful Soup, probably the most popular scraping tool around. Beautiful Soup is usually used in combination with requests. These are both open source packages for Python. And what it does, it downloads the entire HTML of a website, and then Beautiful Soup provides CSS selectors, filters, and modifiers to extract specific data. On the cost side, it is absolutely free to use, but you will have additional LLM costs if you use AI to extract the data, which I will show you in a couple of minutes. And without cleaning, you end up spending a lot of tokens because you get the entire HTML. In addition to that, you might need a proxy depending on the website you want to scrape. So a proxy server is an intermediary that sends the requests instead of your client. And this way you can appear more human-like, or you can rotate IP addresses or use only IP addresses of a specific country. And this helps to prevent being blocked from scraping specific websites. So let me show you this in action. So what you're usually doing is you're inspecting the HTML and then finding a way to select the data you want to scrape. Let's take a look at a basic Python script that uses requests and Beautiful Soup to scrape this website. So here in Python, we import both of these packages, and then we specify the URL we want to scrape. Then usually you define a header which mimics human behavior so that you're not getting blocked instantly. And then you download the HTML with the requests package. You initialize Beautiful Soup. And then what we're doing here is we're basically saving the entire content in an HTML file. And here with Beautiful Soup, this is now where the magic starts, is we're selecting all these job listings. We're looking for list item tags, which have the class flags and border and so on. So I don't want to go into too much into the details, but you will see here that we loop through each job and try to find the company name, description, and the job title, job type, location, and so on. And then at the end, we append everything to the list and print it in the console. So let me show you this in action when we run this script with Python 3 soup.py, because this is the name of my file. Then it should scrape this information for us now. And as we see, it successfully scraped exactly what we wanted. So the only issue now is if the website owner here, in this case Y Combinator, if they make changes to the website, change the class names and so on, then the scraper is not working anymore, and we need to start from scratch and fix these problems. In addition to that, if we look at the HTML file that was generated, how many lines we got here, 2,600, 700 lines. And if we copy this now and want to use AI to extract the data, and we head over to a token calculator, input the HTML here, we see that this equals over 65,000 tokens. So what does this mean? A token is basically a fraction of a word, and you end up paying for the tokens you put into the LLM and also for the tokens that you get back as a response. And this tool here on OpenAI, I just used it to estimate this. Each model and provider, they calculate it in a maybe slightly different way, but it just shows you that it's a lot. I just want to illustrate that you end up paying a lot if you use this raw HTML as an input. Now let's continue with the AI-powered scraping tools. One tool I tested is Jina.ai/reader. And what this tool does, it converts the HTML to Markdown and already provides you a cleaned up output. So this is super LLM friendly and will save you tons of tokens. In addition to that, it is cloud-based. It's super easy to use. You can just use the API. On a cost side, it is also almost free to use. So you will get 1 million free tokens, and then for only $20, you get 1 billion tokens. And I did the math. You can basically scrape this job listing site 125,000 times for $20. So that's incredible. So in addition to that, you also need an LLM to extract the data from the markdown you get from China. And you will also need a proxy server for difficult to scrape sites. I will show you this now. You see here how to use it. You just need to add r.jina.ai in front of your URL. So here in this UI, you see how this works. We enter our URL here. It adds this prefix in front of it. And then when we start clicking on get response, we should get now the markdown back. So this is now the website in markdown format. If you copy this and go to our tokenizer tool, then we see that we only need to spend roughly 7,000 tokens. So that's almost 10% of the cost compared to beautiful soup. The only issue now is that with some websites, you will need a proxy to scrape it. And if we enter, for example, this Argentine website, then let's see what response we will get. So you see in this case, we will get a 403 back, forbidden, verifying you are human, and so on. So in this case, this scraper is completely useless. And we would need to at least add a proxy IP address. But we can also do it here. I saw this in the settings. So here, use a proxy server, and here you would need to add a proxy server. The next tool on my list is called Firecrawl, and it is also LLM friendly. It will also give you Markdown or a JSON output, and it has built-in proxy handling. So it basically does everything for you, and it even has an extract mode. That means that you don't even need an LLM anymore. So it can already extract data from the Markdown or JSON that you want. On the cost side, you will get 500 free requests on sign up. And after that, they only offer a monthly subscription. So they don't have a pay as you go plan. And it's starting from $19 a month. I did the math. You end up paying 0.64 cents per request if you max out the maximum of requests you can send for these $19 a month. And the extract mode costs 5 times more. So you can multiply the 0.64 by 5 if you want to use their LLM. Otherwise, you can save a lot. I mean, by using your own LLM. which I will show you in a few minutes. Let's look at that as well. We go and head over to firecrawl.dev and we sign up, and we head over to the dashboard. We see that there is a playground that they provide. And if we now use the Y Combinator page again and enter it here now and click on run, it should scrape this page for us. So we can see it was also successful. We got it back in Markdown or JSON, which contains the Markdown. So let's copy this Markdown as well and check like how many tokens we need to spend for that. And it's even less than with Jina, only 6,553. So on Firecrawl, we can also test the extract mode, which is currently in beta. And I've tested this already. It's not really working as expected. But what we need to do is we add our URL here, and then we can either prompt what we want to get, or we add the schema manually. And in this case, I want to have an object of jobs. If each job contains the company name, job title, and let's say the location. This should work. But if we click run, let's see what happens and what we will get. We see we get only one result here. So I don't know, but I couldn't make this work yet. I think it's better to use our own LLM. So next on the list is a tool called Scrapegraph AI, and this tool offers also an extraction mode and also structured output formats like Markdown and JSON, and also this kind of schema definition that we saw now in this extract mode with Firecrawl, but works way better. And on a cost side, you get 100 free requests on sign up, and then they also only offer monthly subscriptions starting from $20 a month. And if you do the math, you end up spending 0.8 cents per request if you use your monthly request limit. And also 5 times more expensive if you use their extract mode. So it's very similar to Firecrawl, but yeah, let's see it in action. So we head over to their website and we sign up and log in. So when we are logged in, we end up on the dashboard, and here we will paste our job board website again, and we can now prompt what we want to get. So let's say extract details for each job, like company name, job title, and location. So let's run this and let's see what we will get. So it took a while, but now we see that we actually got all of the data, company name, job title, location. So this tool works perfectly fine. Next on the list is a tool called AgentQL, and this also allows you to select data via natural language, and it can perform actions for you in the browser. For example, filling a form, clicking, scrolling, etc. So way more advanced, and like as the name already suggests, it has some agentic features. So it has Playwright integrated. This is a headless browser solution, and it's also providing structured data output for you. On the cost side, you get 300 free requests for testing when you sign up, and then they have a pay-as-you-go pricing, which is about 2 cents per request. So let's see this in action as well when we head over to their website and we sign up. We can also test some of their features in the playground. So we head over to the playground and it creates a screenshot on the right. So you see the entire page. And now what you can do is specify the schema here, like we did before already. So yeah, let's leave it like that. And let's click on fetch data and let's see what we'll get. And it looks like very complete. So excellent. For these agent features like filling a form, scrolling, clicking a button, we actually need to write a little bit of code. I looked into the documentation, did that already, and prepared an example just to show you how this works. So let's say we want our agent to fill out this form here and submit it. Let's head over to our code. So this is an example I found in their documentation, but I had to tweak it a little bit to make it work because it was not working right away. So here we have some imports, and then we specify the URL here where we want to perform the agent tasks. And what it basically does, it's spinning up a playwright headless browser, and then the AgentQL wraps around it. And this allows us now to use natural language to query the fields. And here in this form query, we actually describe all the fields we want to have. So in this case, the first name, this is here, the last name, email address, subject of your inquiry. Then I added here select so that the AI recognized that this is a select field. Then the comment and the continue button. Then we need to specify the input of these fields. We have a click function here. So it will click the button after filling the form. And then after that, there will be another button, a confirmation button. So this is queried here and then clicked again. And then we wait for a ready state from this page. We wait for 3 seconds and then we print form submitted successfully. In order to run this, we type python3 main.py in this case, and then it should open up a new browser window. And here you will now see what it does. So let's see if it's able to fill the form. Yes, took a few seconds and also clicked on confirm. Perfect. The last tool I want to talk about is Crawlee. This is an open source framework for building scrapers developed by Apify. And this is probably the most sophisticated solution. It has already built-in tools like a proxy rotation, infinite scrolling, and so on. It also has browser automation with Puppeteer or Playwright, and it can be hosted easily on the Apify platform. On a cost side, it is free if self-hosted, or if you deploy this on Apify, you get a $5 usage or credits worth $5 every month. After that, I made the math and it cost me roughly 3 cents per request for using the proxies and 8 cents per request for the Apify hosting. So this is more like on the expensive side. So what is Apify? Apify is a platform where you can find ready-made scrapers and where you can also deploy your own scrapers, and you don't need to take care about the hosting and all of this infrastructure stuff. So in my case, I couldn't find a ready-made scraper on their platform that was able to scrape the pages I wanted to scrape correctly. So I decided to give Crawlee a try and code a little bit. And I will also show you a code example of a Crawlee scraper. A simple Crawlee scraper basically only consists of two configuration files, the main.ts and the routes.ts. And here in the main file, we specify the main configuration. For example, we can set a start URL, but this can be overwritten later on. And we specify the proxy configuration, so we can use the Apify proxies here, which is very useful, and set some other configurations. For example, how many pages we want to crawl. So I set this to 1 because I only want to scrape the start URL. And here in the routes, we can basically specify what we want to extract. So in this case, I try to clean up the HTML already a little bit and remove these common tags that I don't want. And then here I convert the HTML to Markdown using an external package. And then I save the results here in an object with URL, content, and the timestamp. And what I can do now, when I install the Apify CLI, I can just say Apify login with my account details or my API token, and then I can say Apify push, and that will push the code to the Apify platform, build it there, and deploy it, and I can already use and test my scraper. And here on my Apify dashboard, I can see the code that I just pushed, and I have a web IDE here, so I can make changes right in the browser if I want. And now if I specify this real estate site here as an import, and I click on start, then it should start scraping this page for us. So now we see it finished after roughly 1 minute, and we spent almost 5 cents on this.
Yeah, well, who cares? I got money to burn.
And now we can download this in different formats. So let's just view this in a new tab. And here, yeah, we see we got some markdown data here. So this is also working. And let's see how many tokens these are. We go back into the token calculator. 17,000. So yeah, it's because I try to clean it up a little bit, but it's not as perfect as with these previous solutions. Now that we've got our data, let's talk about picking the right LLM model to process it efficiently. So I came up with a kind of decision framework which consists of 5 different factors. The first one is performance. So obviously performance is very important. So we need to pick a model that's able to extract the data that we want. But it's a balance also between the cost and other factors. Regarding the cost, there are huge differences between different models. If it's a reasoning model, if it was built in China or in the US.
China.
I always try to go with the cheapest model first and see if it's able to perform the job. And if it's not smart enough, then I go one step higher and pick a better model. So that's how I go with this. Another aspect are the features that this model provides. An example is structured output. So is this model able to output JSON, for example, consistently, or does it hallucinate and so on? Then the token limits. While the input token limit is rarely a problem, take for example the new Gemini 2.0 models, which support up to 2 million input tokens. The output token limit is oftentimes the limiting factor. Depending on the model, you only get between 4,000 to 8,000 tokens back as a response. So this is like something to test if it's enough for your scraping job, or if you need to come up with some strategies to limit the output. Last but not least, there are specific use cases where some models perform better than other models, for example, math or coding and so on. So that's the fifth factor of my personal decision framework. Regarding the costs, I just want to visualize this. Let's go with a simple example of scraping product pages. Each page generates about, let's say, 20,000 input tokens and 5,000 output tokens, which is very realistic. And let's say we want to scrape 100 pages. With GPT-4o, this would cost us $5.05 in total. With GPT-4o Mini, this would only cost us 30 cents, while with Google Flash, it would only cost us 15 cents. With DeepSeek V3 would cost us only 14 cents. And with Llama 3.3, this would cost us more or less 37 cents if we host this on Azure, for example, because it's an open source model. And with Claude 3.5 Sonnet, this would cost us $7.56. So a lot more, most expensive model. As you can see, it really depends on the model, and you should check the price chart of each model. And if you decide on using an open source model, you can consider self-hosting it maybe. Some of the bottlenecks I recently encountered is, for example, accuracy. And a way to solve this is to try different models with the same prompt and then see which one performs better and which one worse. And this is a way to find the ideal model. Structured output is really important if you want to use the app within an application and you need to rely on getting the same output structure. So in this case, I like to use models that have a parameter for that. So I can select, for example, a JSON output, and I always get a JSON output back, no matter what. So another bottleneck are the token limits that I talked about already. So especially the output token limit, and a way around this is, for example, to use a chunking strategy. So breaking down a large input text into smaller units to avoid exceeding the token limits on the output side. Now that we've also got our model, let's tie everything together in an example application. So for that, I just want to share the app architecture of the scraping dashboard that I recently built. So we have a front end that I built with Vue, React, and TypeScript. This front end is sending scraping requests to the backend. The backend is built with Fast API and Python and uses a simple SQLite database for now for this prototype. And the backend fires up the scraping job. Scraping is in this case done via Firecrawl. Then there is an additional cleaning and chunking step of the markdown that we get back from Firecrawl. Then we use this as an input together with a prompt for a Gemini model. And the Gemini model responds with a structured JSON output. And we take this JSON and convert it into a CSV file via the pandas package in Python. So this is the basic simplified architecture of the AI scraping dashboard. Enough theory, now let's perform a test case. So for that, I will go to the real estate site and filter out some listings that I want to scrape. So in this case, I just select something I want to scrape. So we see we have 1,600 roughly apartments listed here. We copy the URL and we go to the dashboard and create a new scraping task, paste the URL here, and here we can now specify like how many pages we want to scrape. Let's pick 4 so that it won't take too long. You can also enable notifications here, and we click start scraping. So this runs now entirely in the background, so we can do something else. We can create another scraping task here, or check out the other pages, so that we have a credits page, for example, here, where we see our available credits. We have different packages here where we can buy more credits. Currently, not implemented yet, the payment processor, but a feature that's planned for the future, 4 credits deducted. When we go to the downloads page, and the scraping task is completed successfully, then we will see another row here and an option to download the file. So let's go back to our dashboard, and we see it's still in progress. Now that it finished, we can go to the Downloads tab again, and we see the output here, which we can download. And when we open this file now, we see our successfully scraped data. Perfect. Now let me show you the most interesting part of the code base, where I perform the scraping and the AI processing. First, you see a bunch of imports here. Then we configure Gemini with our Gemini API key. Next, we define a schema of the data we want to extract. This is my main processing function, which takes the task ID as an input. Then I initialize the notification service and the Firecrawl service. Next, I get the task from the database and update the status to processing, and also make sure that the pages scraped count is set to 0. So after that, I create a checkpoint directory. So I implemented a checkpoint system in case the scraping job fails in between. It can be resumed from the last successfully scraped page. Next, we have the pagination logic. Because I built this specifically for this real estate website, I just switch between pages by modifying the URL. I check here if the page was already scraped. So this is part of the checkpoint system. Finally, I scrape the current page here using Firecrawl, and I get a markdown back. So the markdown is then additionally cleaned here, and then the model is loaded, in this case Gemini 1.5 Flash, which was absolutely sufficient for my job. And I have a prompt here where I input the cleaned markdown. After that, Gemini is generating the content, and I can specify here that I want to have a JSON back, and also input the response schema here, which I defined earlier. So after that, I save the checkpoint for this page so that this is not lost in case the job breaks suddenly, and update the pages scraped of the task. After that, if we loop through all the pages, we combine them here and finally generate the CSV using pandas. So this is very straightforward. We set the file name and the file path, and then write the CSV file, clean up the checkpoints after successful completion, and update the task status to completed. So then we send a completion notification to the user in case he enabled this option. And at the end, we just have some error handling here. I hope this wasn't too complicated. Let's wrap this stuff up with some future features and ideas how this dashboard could be improved even further. One feature that I like to explore further is data enrichment. Imagine you take one of these scraped real estate listings and use this as an input for another LLM call. And this time the LLM searches the web for the address and responds with like maybe some crime statistics, a walkability score, or an infrastructure score and stuff like that. And you add this extra information to the CSV file in an extra column, for example. So that's like kind of augmented scraping. Another feature is task queuing that Crawlee, for example, has already built in, but that's something that's really important as soon as this dashboard is used by several users simultaneously, so that I make sure that my server is not overloading. Another feature is multi-format support, so that the user can export not only CSV, but maybe also in PDF or other file formats. Then I already mentioned the payment integration that I haven't implemented yet, but that's something that is really cool. For example, integrating Stripe and then enabling users to just simply top up credits. What I can also think of is a storage integration, so that is a kind of synchronization with OneDrive or Google Drive, and data is either stored there or in an object storage, or maybe a combination of both. Another feature I can think of are custom fields, which enable the user to select which fields he wants to scrape or not, and instead of hard coding it, so the schema will be dynamic in this case, more or less, and the users will be also able to save specific configurations as templates. Last but not least, there could be some analytics features, maybe in a separate tab, using some of the popular data science packages and just analyzing the scraped data programmatically and creating some charts and metrics and calculations with that data and display it as charts and diagrams. That would be also really cool. Yeah, that's about it. If you want to stay up to date with AI, scraping, new tools, ideas, opportunities, you can find my free newsletter below in the description. Also, let me know in the comments if you like to see a specific scraper built in detail. I'm thinking of doing a deep dive series on building specific scrapers for different use cases. All right. I hope you enjoyed this content. See you in the next one.